Okay, hi Zach, welcome to lesson number 74. And this lesson goes over scientific notation. And I'm just going to start by telling you up front, this is probably not my strongest suit because it can be a little bit complicated and it's easy to mess up the numbers because of all the zeros involved and multiplying by 10 and divided by 10, not just 10, but like 10 to the 5th or 10 to the 10th or something like that. So it's a little tricky, but I know that you're going to get it right away because you are really good at this kind of stuff. And it's important because otherwise you look like a weirdo like this guy because he's like, you didn't use scientific notation? It's cool. I'm sure that 0.00000098 will look great in your lab report. And this is why you use scientific notation, right? Because you don't want to write a number like that. 0.0000. I mean, who wants to write that? And when you do write it like that, it's really easy to make a mistake. But sometimes there are numbers that are actually that small, that are relevant, or there might be super ginormous numbers, right? So in the lesson, it talks about sometimes you have to multiply 1,000 times 1,000, like times a really humongous number if you're trying to figure out something like this. So this is the thing. What if your problem says, find the number of molecules in 1,000 liters of gas? Okay. So 1,000 liters, 1,000, you would have to multiply, so the number of molecules, you have to get liter down to something small. So instead of liters, you might get it down to like cubic centimeters. To do that, you're going to multiply 1,000 times 1,000. And then this number, look at this number. I actually wrote it all out for you. This represents the number of molecules in a cubic centimeter of gas. So this is what a cubic centimeter looks like. At least it's about a centimeter when I drew it on my iPad. You're probably looking at it on your phone or something like that. But the number of molecules in a cubic centimeter of gas is this number. So you have to get down liters to cubic centimeters, and then you multiply it by this number. So who wants to do that? That's going to be humongous, and it's super easy to make a mistake. So we don't want to do that. So instead, we use a mathematical shorthand. And what the book describes is like, did they teach it to me like this? Because if they had, this would be super easier for me to understand. And I don't remember learning this. But it's basically the Dinuskwer rule. And you remember the Dinuskwer rule, if you multiply the same thing, the numerator and the denominator, it doesn't change the value of the fraction or the number or whatever you're working with, right? So if you have a number like this, look at this number, 0.0000416. And you don't want to write that in your lab book. What you would want to write ideally is to put the decimal instead of there, put it like right after the 4. That's where it typically is. 4.16 times 10 to the something, right? So we're going to figure out how to do that. All right, so you have this number and you want to turn it into a more useful number, times 10 to the something. And that's how we do scientific notation. So what you do is you do the Dinuskwer rule. The Dinuskwer rule means let's turn this into a fraction. And then this is going to be just that over 1. There's your fraction. And we're going to multiply the top and the bottom by the same number. Okay, and so in this situation, what we do is we figure out how many times do we want to move that decimal. So I'm going to look at the decimal, it's here, and I want to move it 1, 2, 3, 4, 5. So I want to move it 5 places. So I'm going to multiply the top by 10 to the 5th, and I'm going to multiply the bottom times 10 to the 5th. And that way I don't change the value of the fraction. I don't change the value of that number at all. So what I get when I do that is I multiply straight across. Now I'm just going to make this a little smaller so I have enough room. Okay. But I multiply it straight across. So what I get is, let's do a different color. This big number times 10 to the 5th, and it's just going to be 4.16 now. And on the bottom, it's going to be just 1 times 10 to the 5th. So that means it's just 10 to the 5th. Now you know, and I know, that when you have something like this on the bottom, you can change the exponent and move it to the top. So scientific notation would turn this number into 4.16 times 10 to the minus 5. And this is your final answer. This is scientific notation. It's the same as that tiny, tiny number. Okay? But it basically tells you how many times you need to move the decimal so that this number is actually what you think it is. Okay? That's it. That is it. So that is really cool to me. And that's basically, that's it. That's so cool. So when we look at numbers written in scientific notation, and it's going to be something that looks like this, 4.16 times 10 to the something. Okay, and this is a positive number here. It could be that. And this is a negative number here. And what you want to do is you want to think about this part of it as a decimal point indicator that tells you where the decimal point really is. So is this going to be a super huge or a super small number? Okay, and same with this. We just changed a super small number into this, and we got 10 to the minus 5th. Remember? So if you have a negative sign here, that means that the decimal point is really b places to the left. 1, 2, 3, 4, all the way to b, whatever b is. So when we did 10 to the minus 5th, this would be 5 places over. 1, 2, 3, 4, 5. It's off the screen. So you would have to add a bunch of zeros. So in this situation, I'm going to, let's see, I think I can select this. Maybe. Sorry, I'm trying to, let's delete this. Oh my goodness. Let's see if I can erase it. Maybe I can erase it. There you go. I did it. Okay. I had something hidden underneath. So you move the decimal over, not over. Oh, no, that's not what I want to say. I want to move, I must have erased the M. I want to move the decimal b places to the left. So it's actually going to be a super, super small number. So maybe that's how you remember it. If it's a negative b, it's probably going to be a super small number. If it's a positive b, it's probably going to be a super humongous number. Let's do this one then. 4.16 times 10 to the b. So b is the indicator telling you how many places you move the decimal, this time to the right, because it's a positive number. So in this situation, let's erase this. There we go. Oh, poop. Oh, well, I tried. You move the decimal b places to the right. Okay? So instead of 4.16, it's going to be 4. Like the decimal was here, we're going to move it blah, 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 however many b is, and it's going to be a humongous number, and it could be really, really huge. Okay? So when it's a positive number like this, it's probably going to be a huge number because you're moving the decimal to the, you're multiplying it by 10 to the 5th, or multiplying it by a huge number. Remember, this is like you're dividing by 10 to the 5th. Okay, so that should help you figure out where to put the decimal. And the whole purpose of doing this is that you don't have ridiculous numbers in your lab book. Okay, it's a shorthand method of writing ridiculously small or ridiculously big numbers. Okay, all right, so this one, let's look at this. This is halfway down on page 302 for you if you want to look at it. So we have this number, 4.165 times 10 to the minus 7. So the decimal is really 7 places to the, is it going to be to the left or to the right? Okay, it's going to be to the left. Why? Because this is like dividing by 10 to the 7th. So it's going to be a super small number. So we're going to go 1, 2, 3, 4. It's off the screen. It's super small. So I'm going to write 4165 over here, and I'm going to add a buttload of zeros. And let's see if we get to it. Okay. So the decimal is here. I'm going to move it 1, 2, 3, 4, 5, 6, 7. Look at that. I added the perfect amount of zeros and I didn't even realize it. So this is the actual number. When you see this, the actual number is this. But obviously you don't want to write that lower one in your lab book. And it's just too easy to make a mistake. Okay. Now, what if you see this? 4.165 times 10 to the 7th. That means the location of the decimal is 7 places to the right this time, right? Because you're multiplying this number by a super humongo number. All right, so let's see if I can do this again. 4165, I'm going to add a buttload of zeros. Okay, well, we'll try that. Okay, so if the decimal is here, I'm going to go 1, 2, 3, 4, 5, 6, 7. Okay, so it's actually going to go right here, and I can get rid of that. I can probably get rid of that. It's actually this number because the decimal is at the end. Okay, so that's what this number is. And you can see, I bet you can already anticipate what kind of homework questions you're going to get, because this is where people make a mistake. Is it going to be a super huge or a super small number? Do you move the decimal to the left or the right? Blah, 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 right? Okay, so from there, it can get a little bit more complicated because there's actually a 2-step process to write a number in scientific notation. Okay, put the decimal after the first non-zero digit. So if you have something like this, a number like okay, where do you put the decimal? So the decimal, where do you want it? It's going to be here after the first non-zero digit. So it does not go here because that's a 0. You put it after the first non-zero digit. Okay, so this is going to shorten to 3.07 times 10 to the something, right? Okay. And then you follow it with the proper power of 10 that shows the true location of the decimal. All right, so let's do it with this number. So this is a super humongo number. We don't want to have to do math with that, and we don't want to have to write that lots of times. So let's write it in scientific notation. The first step is to figure out where the decimal should go. Okay, after the first non-zero number, so that's going to be here. So what we really want it to be is 7.146. And this is going to be 7.146 times 10 to the something. Is it going to be a positive number here, like positive something, or is it going to be a negative something? Well, since this number is super huge and we want to multiply this by something to make it huge, this is going to be a positive number. And then what's the positive number going to be? It's going to be 1, 2, 3, 4, 5, 6, 7, 8. Because you have to move the decimal 8 places to the right. Choose the right. Actually, that could help you remember, because if it's positive to choose the right. It's positive to choose the right. When it's a positive number here, you're going to be moving the decimal to the right, making it a humongous number. Okay? Alrighty, now let's jump into some examples. Here we go. I know, this is probably how you're feeling. I know, it's okay. We got this. We got this. We can do it. Okay, this is example 74.1 on page 303. Hey, we passed 300 pages of math. Woohoo! All right, so we want to write this number in scientific notation. This is a super small number, and we don't want to have to write this lots of times, right? First step, where's the decimal going to go? It's going to go after the first non-zero number, so here, 3.16. 3.16 times 10 to the something Is this going to be positive or is it going to be negative? Well, we're going to have to move the decimal from here. We're going to have to move it to the left. So that's not choosing the right. It's going to be negative. And that makes sense because we're going to end up having a super small number. Okay, so it's 3.16 times 10 to the something. And then what do we have to do is just figure out how many times we move that decimal. So I'm going to zoom in on this. Let's zoom in here. Okay, we want the decimal here, but it started out there. How many places do we move it? 1, 2, 3, 4. Okay, so it's going to be 3.16 times 10 to the negative 4. Okay, sweet, right? Easy peasy. Now let's make it harder. Just when you think you got it, you're like, bring it on. Let's do this. Example 74.2. Write this number. Oh, poop, I just erased the number. This number is super small, but it says times 10 to the, oh, look at this. Who did this? Who did this scientific notation? This is nonsense. Why would they do this? All right, they want us to fix this. Write this number in scientific notation. It's already times 10 to the minus 7, so why didn't they just do it properly? The decimal should be here, but it's not. It's here. So what do we do? The first thing is I'm going to zoom in on this number. Okay. And then I'm going to rewrite the whole thing so that the decimal is here. Okay, so I'm going to write 3.16 times 10 to the something. All right, now, let's say I'm just going to ignore this part for now. How many times do I move this decimal? 1, 2, 3, 4. I'm moving it 4 to the left. 4 to the left is a negative 4. 4 to the left is a negative 4 because not choosing the right, it's not being positive. I got to go negative. That means to the left. Okay? Now, I'm going to take this thing that I was ignoring before because it's still part of the original problem, and I have to multiply that back in times 10 to the minus 7. So now I've got 3.16 times 10 to the negative 4 times 10 to the negative 7. What do you do with exponents that you multiply together like that? You add the exponents. So we're going to add negative 4 plus a negative 7. And what do we get when we add that? Easy peasy. We're going to get 3.16 times 10 to the minus 11. Okay, sweet. We did it, right? We did it. Let's do the next example. All right, this is to motivate you to keep practicing your juggling. Look at this guy. Whoa, what the? He's amazing. Did you see that? This is going to be you. This is going to be you. That is sweet. All right, just imagine that, huh? All right, now it says write this number in scientific notation. Look, it looks like someone put it in scientific notation because they have times 10 to the 7th. But they didn't do it properly. That's not where the decimal goes. It should be here. So we have to fix this. This is nonsense. So let's pretend you're a science teacher and someone writes this in their lab book and you're like, what the heck? No, you got to fix it. All right, so let's start by fixing where the decimal should go. 3.16, that's where it should go. Duh. Okay, now how many times did I move the decimal? I moved it 1, 2, 3, 4. So we are starting here. If you start here and you want to get to this, you're going to have to move this decimal. You're telling someone to move it to the left, right? So this is going to be 3.16 times 10 to the minus 4. I moved it 4, right? 1, 2, 3, 4. Yes. Now I've got to bring this down. Times 10 to the 7th. Okay, so now you've got this big thing. And what do you do when you multiply 10 to the minus 4th times 10 to the 7th to positive 7? You add those exponents. So it's 7 minus 4, which is 3. So it's going to be, the answer is going to be 3.16 times 10 to the 3. That's actually easy to do in your head. So if you wanted to write the actual number, it's going to be 1, 2, 3, 1, 2, 3. This is the actual number. That's the actual number. Probably doesn't even need to be written in scientific notation. That's the actual number. All right, let's do the next one. I know you're probably like looking like this lady right now. Another one. Oh my heck, I get it, Mom. I get it. Do you? Do you though? Because these get really tricky. All right, now let's say you've got a number like this and they want you to write it in scientific notation. Easy peasy. Let's figure this out. Where does the decimal go? Well, let's see. It goes after the first, whoops, I did the comma like it was a number. Okay, so it's going to be right here. Okay, and it's going to be times 10 to the something. Is it going to be positive or negative? Well, you're turning it into a bigger number, and you're telling someone that you want them to take this number and move the decimal to the right. So this is going to be a positive number. Choose the right. It's positive to choose the right, right? Okay, so let's do that. 4.78 times 10 to the what? It's going to be 1, 2, did I do that right? Yeah. 3, 4. So it's going to be times 10 to the 4th. Okay, sweet. Let's do the part B. Turn this into scientific notation. Oh, again, you've got a student that did it wrong. This is going to be 4.78. And you're basically turning this number into a bigger number. So you're telling someone to move the decimal to the right. So you're going to have to do times 10 to the positive number. But what is that positive number? It's going to be 1, 2, 3, 4. So this is times 10 to the 4th. But you've also got this 10 to the negative 7th that you've got to add in. So we're going to go times 10 to the minus 7. What do you do when you multiply? You add the exponents. Negative 7 plus 4 is going to be negative 3. So I'm going to erase this, and I'm just going to put negative 3. Did I get it right? Yes. Hallelujah. Hey, I'm getting good at this scientific notation. I used to think it was super hard. I didn't have someone explain it like that, where it's the Dinesquire rule. I can't believe it's the Dinesquire rule. I didn't know that this whole time, because I was like, why do you do times 10 to the minus 7? That's so weird. Anyway, that totally makes sense now. All right, they want us to write this in scientific notation. And again, looks like someone started to. They did that times 10 to the 7th, but they didn't do it properly. So the decimal should go here after the first non-zero number. So what does it mean? You're turning this number into a much bigger number, which means that you are telling someone to move this decimal to the right. To the right means a positive exponent. So how much to the right? 1, 2, 3, 4. So it's going to be times 10 to the 4th. Now we can't forget about that 10 to the 7th where we started. And let's add those exponents. 7 plus 4 is 11. And we're just going to change this to 11. Okay, that's the answer. And that's what they got in the book. Sweet! And now you get to go and do it. All right, have fun doing your math today, Zach. Love ya. Bye.